Hello students and welcome back. So now we are going to talk about the test bench writing in Verilog. That means we can use text-based coding and write the test benches instead of using the GUI-based simulations. So in this video, we are going to talk about that what exactly is a test bench, how can we generate the stimulus for the design, how do we initialize a test bench, how are we going to integrate our design and test bench, and then how can we define different test cases in the given test bench. So let us get started. A test bench is very important aspect in Verilog coding. When we have multiple inputs, then generating the individual test cases can be quite tedious using the waveform method, and in those cases sometimes we need only a specific test cases. I'm getting a problem in one test case, I just want to measure the output in that case. In all such cases we can write the stimulus file, and that is called the test bench file. We can also mention all the test cases, but we have the flexibility that we can mention the test cases of our choice only. So in a test bench file we are going to generate by using the add resource option that we get in the project manager. Normally we add the Verilog file using that, right? So we will use the same option. We are going to describe a new module which is very similar to design module. We will instantiate our design module inside the stimulus, that means inside the test bench, so that we know that this particular test bench belongs to this Verilog code. Then we will initialize the simulation by giving the initial conditions, and with some delays we are going to define more test cases, and then we can also mention that when should we stop the simulation. So now what we are going to do, we will do it directly on Vivado and see what are the things that we need to take care while writing a test bench. So we are in a project where I have some sources. These are the design sources. Now we will click on add source, and here we will select this option, add or create simulation sources. Then we say next and create a file. It will still be Verilog, okay? Do not think that it will be something else. It will still be Verilog, and I can say test bench underscore half adder underscore data. So this is the test bench for a half adder which was designed using data flow modeling. The name is all up to you. Only thing that you should take care that do not keep the same name which you have for your Verilog file. Now we say finish. Here we will not mention any ports. So this you have to keep blank and just say OK. It will warn you that you have not mentioned. We say fine and we click on the yes. Now in the simulation sources you will find your file, and here is HA data test bench. Now we open it and we can see that this is a blank file. You can also bring this bracket here. So this is very crisp code, only 2 lines are here. Now the first thing is writing the variables. Here first of all we'll go to the half adder and see what are the names here. These are A, B, sum and carry. A and B are inputs, sum and carry are output. In a normal Verilog code we take inputs as wires and outputs as register. In the test bench we will take exactly opposite. That means input variable will be registers and the outputs will be wires, and you are free to choose any names. So I say registers A comma B, I am still taking the same names, and I say wire S comma C, here I have taken different names. So this is first thing. Now I need to connect my test bench with Verilog code. And how do we connect? Well, using the module instantiation. So I say HA underscore gate, and then you can instantiate using the ordered or the numbered method. Anyone is fine. You call them by name or by order, anything is fine. So I am using the order method. The order was A, B, sum, carry. So I am giving A, B, S, C. So now this is also fine. Now we have to initialize. So we say initial, begin and end. Okay. So always write end whenever you write begin, otherwise there can be confusions later. And here I am going to mention my test cases. I say hash 10, that means after 10 nanosecond A is equal to 0 and B is equal to 0. So for the first 10 nanosecond nothing is allocated, it will be X. Okay. Then after another 10 I say A will be 0, B will be 1. After another 10, A will be 1, B will be 0. And after another 10, this will happen. And after another 10 nanosecond, I can stop the simulation. And for that, I will write $finish. So what I am doing, I am running my simulations with this initial case. Then after 10 nanosecond I am giving a new case, and now you can see that it is not important or it is not compulsory to give these in a specific manner. Whichever case I want to give, whichever I want to miss, it is all fine. We can do that. Okay, now we save it and we will set the top modules. Here this is the test bench. I'll say set as top. And in the design also my half adder is set as top, and we will go to the simulation now. So now what we are going to do, our test bench is set as the highest top level module. We go to run simulation and say run behavioral simulation. This simulation is going to take few seconds depending on the PC that you have. And now we can see that the waveforms are missing, but there are some numbers. Well, the waveforms are not missing, they are here. Okay, click on this, expand this, zoom fit, and you have your test cases. First 10 nanoseconds, 0 to 10, nothing, because we did not define, so it is all X. Then 0 0 0 1 1 0 1 1, and exactly at 50 nanosecond the simulation stopped. We did not click anything here. It happened all because of the script that we had written, and this is what we defined. Now you can imagine what else we can do here. You can write loops for repeated test cases. You can use while loop or for loop, repeat loop. You can also mention test cases using if else, and you can also mention only the 10 cases that you want to have. So everything is possible using this method. So students, now we have seen that how to write test benches in Vivado. We are also going to learn that how to do it on EDA Playground. There is going to be a slight change. Keep learning. Thank you.